Good morning. In this class we wish to discuss the topic a linked list. First, in this we wish to discuss what is abstract data types. Abstract data type is a class for object whose behavior is defined by a set of value and a set of operations. Therefore, in ADT, the data type plus methods be there. The ADT is abstract from implementation details. That is, how data domain is built from more basic data types, how the core methods actually work. Then efficiency of the algorithm for core methods, then correctness of algorithms. Actually, these are the things it will hide. Then we wish to discuss what is a linked list. A linked list is a data structure which can change during execution. Then what are the advantages of that linked list? Its successive elements are connected by pointers. Last element points to null. Head pointer points to the first element. It can grow or shrink in size during the execution of the program. It can be made just as long as required. It does not waste memory space. These are the advantages of linked list. This is the diagram shown in for linked list. Therefore, ABC is the one list. In this, head points to the first pointer, then C is the last node that is pointed by null pointer. Then next we wish to how insertion is we are doing. The details we wish to discuss. Already the list contains A to B, C elements. In this, our aim is to insert one element. The item to be inserted is pointed by temp pointer. Then the previous element to be inserted is pointed by current pointer. Then how we are doing that insertion. First, the temp nest equal current nest. Therefore, the already temp is pointing the item to be inserted. Therefore, the current pointer pointing that the node A, the nest, the current nest is pointing automatically the B element. Isn't it? Therefore, the B element address is stored in current nest. Therefore, current nest is first assigned to temp nest. Therefore, the temp pointer address in the temp pointer address nest now pointing to B node address. Therefore, this is the pointer is frame. The nest current nest is assigned to temp. Therefore, these are the important two steps. Temp nest equal to current nest. First step we are assigned, then nest current nest is assigned to temp. Therefore, this is the function for initiation. This is the partial statements, or this is the important statements for initiation. Then next we wish to go through that illustration of deletion. Therefore, the node to be deleted is first pointed by the temp pointer. Therefore, the previous node is pointed by current pointer. Therefore, in our diagram, the node A is pointed by current pointer, and node B, that is the item to be deleted, that is pointed by temp pointer. Then current the temp nest is pointing the C element. That address is temp nest is first assigned to current nest. Then, if you go through that deletion functions, temp equal to current nest, then current nest equal temp nest. Therefore, temp nest is assigned to current nest. Then now we are freeing temp. Therefore, this is the procedure for deletion. Then next we wish to discuss array list versus linked list. Actually, what are the types that is suitable for? Arrays are suitable for inserting, deleting element at the end. Randomly accessing any element, then searching the list for particular value. Then linked list are suitable for inserting an element, deleting an element. Therefore, any element to be inserted or deleted, that is suitable for linked list. Then applications where sequential access is required. In situation where the number of elements cannot be predicted beforehand, that's also suitable for linked list. Then next we wish to go through that types of list. Depending on the way in which the links are used to maintain adjacency, several different types of linked list are possible. Therefore, one by one we wish to discuss. First one is linear single linked list. Simply we are telling linear list. Therefore, this is the example for linear list. Therefore, this is the example for linear list. Therefore, head is pointing the A node, then A nest. A node nest is pointing B node, then B node nest is pointing C node, then C is representing null pointer. This is the end pointer. And second one is circular linked list. A pointer from the last element is in the list points back to the first element. Therefore, that is the difference. Therefore, the above one, the last element pointing the null node. In this, the last node pointing to the first node. Therefore, this is circularly pointing. That's why it is called circular linked list. And next one is doubly linked list. The point is exists between adjacent nodes in both the directions. The list can be traversed either forward or backward. Usually, 2 pointers are maintained to keep track of this list: head and tail. Therefore, head pointer points to that first node, then tail pointer points to the last node. Therefore, in this 2 pointers be there. Therefore, A is the pointer node. In this, the next pointer pointing the next node, but A is the previous pointer point to that previous node. But in this case, that is pointing down because the head is the pointer pointing the first node. Therefore, A node has no previous node. That's why it is pointing null. Therefore, this is the diagrammatical representation for doubly linked list. Then next we wish to go through that the basic operation in a list. What are the operations are possible in this? First one, creating a list, traversing the list, inserting an item in the list, deleting item from the list, then concatenate 2 lists into one. These are the operations are basic operations are possible in this. Then next we wish to discuss how we are working with the linked list. Therefore, the structure in this example we are constructed structure student. Therefore, this consists of 3 fields: integer roll number, character name, integer age. Then structure. This is the we are creating the linked list structure struct asterisk nest. This is the pointer pointing the next node. Therefore, this is the fragment of coding used for linked list creation. Then this is the diagrammatical representation for that. To start, create a node and make head points to it. Therefore, head equal to node asterisk envelope size of node. Therefore, we are allocating the memory for this. Then head simply point to that this structure. Roll number, name, age. Then next is the pointer point to the next node. Then there are n number of nodes in the initial linked list. Then we wish to allocate n records one by one. Then read the fields of the records. Then modify the lengths of the